I'd like to introduce Mr. Avinash Khare. Mr. Khare is working as consultant and corporate trainer for new manufacturing technology and automation. Mr. Khare was engaged at Tata Motors Pune for over 3 decades in functions ranging from electronic product and software development to procurement, maintenance, and application of high technology machines and presses. Coming from engineering background, he was majorly engaged with IMTMA for 7 years as head of Pune Technology Center. He worked with designing content and delivering training courses on Industry 4.0, automation, EV technology, vehicle lightweighting, sheet metal forming technologies, and equipment. He has been coordinating international seminars on manufacturing technologies. Today, we are honored to have Mr. Khare as a guest speaker, and he will talk on laser welding automation. So let's welcome Mr. Avinash Khare.
I'll be talking about laser welding automation. Being the last speaker has special challenges and rewards. The challenges are that whatever I wanted to speak, some of it has been already spoken. The opportunity is that the last speaker has to sweep the leftovers. So whatever things need to be added, okay, I can take liberty to add. Okay, so without much ado, let us start. I'll be focusing on laser remote welding within the laser welding parlance. So laser welding automation is the broad title. Now, laser welding and brazing, basically people say that welding is art of inaccuracy because there is a brutal heating and cooling involved, where it is very difficult to ensure any kind of repeatability or even predictability. Therefore, it is always a challenge to have accuracy in welding process. Now, that is where the laser comes to help us, because laser beam gives very intense heat on a very localized zone, and it has much lesser heat affected zone. So without heating the overall parts to be welded, if one can do welding, the heat content is less, and so the accuracy is better and predictability is that much better. And also laser welding is much more amenable to any kind of robotic automation, because I'm sure nobody of us would have seen a robo doing electrode welding. Robo can do TIG welding, MIG welding, but robo cannot gauge how much of electrode has been consumed and so how much and what rate it should be fed. So one never sees a robo doing electrode welding for that matter, right? But there are still many variables when it comes to welding in terms of arc gap, in terms of wavering, in terms of electrodynamic force. Okay. So a lot of welding is dependent on operative skill, and operative skill is becoming costly and scarce. Therefore, automation makes a logical sense. Okay. So to summarize, two major things, advantages that you get in laser is amenability to automation, robotic automation, ease of automating, the flexibility, and also very less heat and very localized heat, reducing the thermal distortion on the whole. So much better control on the distortions, much better control on the thermal effects, which are anyway not very predictable or accurately controllable, right? So that's the art and science of welding. There is another complexity when it comes to welding automation. As it is, welder has to have a lot of hand skill to do a good welding. In addition, if welder has also to walk while welding, walk around the job while welding, that complicates, and it does tell on the quality also. Okay, because he will not focus only on welding, he will focus on walking plus welding. So if we can, through automation, eliminate the walking part, we can index the job, we can have weld positioner, which will move the job instead of operator having to move around the thing. So that much better quality can be achieved even by manual welding if one has weld positioner. And of course, they can always be used along with robotic automation to have a much better overall quality. Coordinated movements of weld positioners with robo. Okay. The trend is that spot welding, which was used heretofore in BIW manufacturing. BIW is body in white for automotive. This is the car body shell. Okay. So car body shell, the specialty is you have very thin sheets, less than 1 mm thick. Okay. So you can't have brutal heating. Okay. it has to be very controlled heating and localized heating. So spot welding was a choice of method used for joining the sheet metal parts which are going in BIW or in automotive car bodies, right? So that is being replaced by a new technology trend which is called uh, remote laser welding or even laser welding. Now, laser welding has many shades. As I have used two terms, welding and brazing. The primary difference in welding and brazing is that in welding, the deposit has a metallurgical bonding with the substrate, wherein in brazing, it does not have a metallurgical bond. It's just filling the gap. So it's like soldering. Uh, and brazing is a word which has come from brass. So when the filler material is brass, we call it brazing. It's as simple as that, right? Now, laser remote welding, I was talking some time back. Now, this is a technology where you throw the laser from a distance. The distance could be more than 1.5 meter, as you can see here. The robo is carrying the laser source and is throwing a laser to the job, to the sandwich of a job, which is held into a fixture in proper position. And through line of sight, it can apply weld. Okay. There are many advantages in this technology. It's also known as scanner welding. Okay. But this is being done from distance. You can't use filler in this one. Okay. So this is like in spot welding also, one does not use a filler. Okay. So it is comparable with spot welding, where you don't have to use filler. You just throw the heat, and with heat, you glue the two sheets with some pressure that is applied by the fixture primarily, right? So that's the technology we are going to talk. Talking of other kind of laser welding, of course, one can have laser welding where filler is used. It could be a wire or it could be a powder, which could be thrown with a nozzle, and on the fly, you can go on doing welding. So it could be, of course, a laser welding using a filler. Now, this is a brief video. It is showing you uh, two technologies. First is welding path, and then there is a brazing path. You can make out from the color of the arc. Now, this is welding. And this is a different arrangement. Now, this is brazing. Because of color, the color, brass color is different. So, the color of flame looks different in case of brazing. Yeah. One is heat conduction welding, where you have a bigger spot. Okay. So energy density is lesser. The depth of penetration is less. So this is called primarily conduction welding, where you use laser primarily as a heat source. As against that, there is a keyhole welding, which is a deep penetration welding, where a vapor plume is generated. Okay. And there is repeated multiple reflections within this cavity. Okay. Causing a depth of penetration. Now, a lot has been spoken about it, so I will go a little faster here. Now, these are the processes, just the description of what is conduction welding and what is deep penetration welding. Now, conduction welding, typically the depth is up to 2 mm. Now, here the energy density is much, much bigger. It is 10 to the power 6 watt per centimeter square. And you can have a depth of as much as up to 25 mm or so. Okay. So, up to 25 mm with sufficient laser power, you can have weld depth of up to 25 mm. And coming to the kind of laser spot that is used, for cutting, you use a very sharp knife. So spot size is much lesser. Okay. Energy is high and beam quality has to be very good. That is, beam divergence has to be very low. Okay. So this is the laser spot used for cutting. This is for keyhole welding, which is somewhere in between. And for conduction welding, you are somewhere here. And if you are doing bulk cladding of powder, that is called laser cladding. That's additive manufacturing actually. So that is coming above this one. So this is the kind of laser variance which is required. Okay. The applications of laser welding, of course, the gears can be laser welded because you can't afford a thermal distortion in gear. So you need to control the heat very locally. So therefore, laser is used for welding gear to a plate, for example. Okay. And multiple gears to be welded together, etc. So these kind of laser welding has been in vogue pretty much since about a decade or even more. The other area where laser welding is used for sheets is, of course, tailor welded blank. Nowadays, people want to have higher strength strips attached to the blank, a bigger blank. So you have a composite blank to be put into the die, and the two sheets have to be laser cut and laser welded or electron beam welded. Okay. So this is a technology where electron beam welding or laser welding is done to prepare the tailor welded blank so that you have combination of higher strength and lower strength in the same part. Okay. Now, as you can see here, the main advantage in laser beam as compared to electron beam or resistance welding is that the laser beam welding, the width of the weld is very small. And when you are doing, let us say, formability simulation, you can ignore the weld part. Otherwise, you have to consider three properties: properties of the left side material, right side material, and the laser weld properties, which becomes the third material. Okay, so that's an advantage of sorts. Okay. Now, coming to laser remote welding, what it is, let me show you this video. So this is a fixture. The parts to be welded are placed in the fixture, the corner reinforcement, the inner and the outer, and the fixture gets closed, and fixture has some holes, as you can see. And then some Diwali happens and the job is done. You did not see the welder, you did not see. This is what it is doing. So from a distance, the pulses of laser are shot through the line of sight and the welding happens. Okay. And there can be features that if the seam is shifting during welding due to heat, you can measure the seam. Actually, you can detect the seam and you can direct the laser accordingly, adaptively. Now, this is called adaptive welding, where remote welding can also be done adaptively. One can have the seam movement detection because, as I said, it's art of inaccuracy. So the seam will go on shifting as the heating takes place, right? The seam could shift left or right. So whatever way it happens, or there could be part to part variability also. You can't have a micron accuracy in a part to be welded, of course, sheet part. Okay. So here the adaptive part comes to our rescue, that you don't have to unnecessarily have lot of accuracy just to have automation. The automation has to adapt to inaccuracy. So that's the trend going further, that automation has to do all the adaptation. Okay. So the automation has to find the seam. Automation has to divert the beam where the seam is. Correct. Otherwise, if you put just the robo will blindly go on following the trajectory. Whether it gets welded or it doesn't get welded, robo cannot know, obviously. So when you say robo welding, it is often turns out to be blind welding. It's like a blind man welding running on a trajectory. Okay. Now here, these kind of things are happening. And one thing you would appreciate that in this kind of welding, actually the XYZ movement doesn't happen. What happens is the angular movement of the mirror, as you can see in this video. With due acknowledgement to Yaskawa, I have taken this small clipping from their bigger video, of course. But you see, as the welding is happening, what is moving? What is moving is only the angle here. Now, it is much faster to move an angle than to move an XYZ, right? So for that reason, the scanner welding is a darling technology because it can do much faster number of spots, etc. Right? So as compared to spot welding, this is anytime much faster. Okay, that's why it is being preferred. Plus, of course, on the adaptive side, now there are two sides of controlling quality. One is the predictive approach, that you do simulation. You do have a lot of empirical data based on past experiential data. You decide the parameters of process parameter, and thereby you get a better quality. The other school of thought is adaptive school of thought, where people are working on combining thermography with welding, where there is a thermographic camera which is sensing the heating, the depth of, and it is modulating the power and speed of welding on the fly. Okay, so that's the future. So adaptive automation is the future, where the inaccuracies and variabilities in the process will get taken care through the automation, and still the quality will be maintained. Okay. So that's my take on quality. Now, this is what I was saying. If the weld seam is irregular, okay, now you have something like a barcode reader which can detect the seam, and it can make the robot to throw the laser exactly at the seam dynamically. One doesn't have to do precise programming. You can do coarse programming with such a wide tolerance. As compared to conventional technology, this is a conventional spot welding. You see, you have to make such a kind of a fixture, these kind of things. You have to make sure that robots don't hit each other. So a lot of software simulation has to be done to ensure the accessibility, to ensure the ergonomics, to ensure that there is no fouling. Now, all these things you can do away with when you do scanner welding or remote welding, as I have shown. Now, here you will see that a robot has to pass through a small hole also. Now, it can very easily hit the job, or robots can collide with each other. Now, all these complications go away once you do remote welding. You see here, the electrode is pushed through the hole. It's very easy to go wrong here, right? Now, these kind of reach problem. So, all these problems get eliminated once you do. And here, of course, there is a cycle time. You have to press, you have to pass current, you have to allow cooling, and then you have to retract. Now, and plus there are so many pythons hanging from the gun, which is a mess, which can entangle. Okay, and operator has to lift the gun. So you have to do simulation of approachability, that something will not foul like this one, and also ergonomics. How tired will the operator be doing spot welding whole day, day in, day out. So these are the advantages when you do remote welding. Another additional advantage is, because with remote welding, you can draw a round spot, square spot, line like this, line like this. There is an opportunity to reduce the flange thickness. Okay. If you do welding like this, you can have a much lesser flange. So you can save on the material as well. Okay. So these are the advantages in summary. Now, basically in conventional laser welding, if there is an XYZ movement after each weld, this is your kind of cycle time with you, and you have to do number of welding. With remote welding, because you are only moving the mirror, it can be much, much faster. So that is the time saved. And this is a study report that 34 spot welds done with 4 robots with 5 spot welding guns. The time was 34.7 seconds. Here it is 13 seconds. Same weld. Of course, the shape of welding is different, but with one robo and one scanner optics, that is one remote welding kit, and you are able to achieve so much saving. So in short, these are the advantages. Basically, low thermal influence, high welding speed, amenability to automation.
Thank you, Mr. Khare, for sharing
I'd love to hear
information
any
about
questions.
laser welding automation.